what you doing, trying to do somebody cold. I just let the music come from my soul, so all of my people can.
All right, I gotta tell you what I did. I went through my all my daughter's music and I tried to find the song that was most annoying, just to mess with you guys. You can tell when I'm getting, if I'm getting bored, I start doing stupid stuff. There's actually quite a bit of annoying uh, uh, music that they have. So, yeah, I'll play some more sometime. So round, round, get around. All right. So more advanced problems, mathematics of finance. Um, what's your most annoying song? I'll tell you what I'll do. Let's have a quiz. First, but are there about 22 of you? I'll tell you, the first. Let's go to the first 10. The first 10 students. Now here's what you got to do. Now here's what you got to do to get points. Email me. So remember, my email address is different than yours. If you can read that, it's .edu. That's maybe the ugliest D. And in the subject line, let's put quiz annoying. Doesn't have to be. It doesn't have to be all caps. And then in the body, put. Then let's do this too. Quiz annoying math 1700. So you got to do all that to get credit. And then in the body, all you got to do is type out the name of the most annoying song, or at least an annoying. I'll never know whether it's the most annoying. In fact, you may even give me a song you actually like, and you're just trying to pretend you think it's annoying. But if you'll do that, this will be a 20-pointer. Okay. Now you may look on my math lab from time to time. This has happened to some people, and they'll email me and they're like, Dr. Darber, how did I miss those 20 points? Well, just prove to me you didn't watch the video, because if you did, you would have known. All right, gang. So an easy way to get 20 points: send me the most annoying song that you have. And actually, that's not the most annoying. I didn't want to spend a lot of time because I've got too much to do, but they have a lot of annoying songs on here, I think, but they're 11 years old. They actually have a Justin Bieber song on here. That's crazy. All right, so I'm sure if they went through my stuff, that they would think that I have annoying songs on here. Anyway, I can't believe I'm sitting here going through my daughter's songs. I need to be teaching. All right, let's get going. All right, let's get this over. All right, guys. More advanced problems, mathematics of finance, part 2. What we're going to look at here is spreadsheets. Now, the next 2 videos are going, or maybe the next one. I'm not sure whether I can get it up and get everything in one video or not. But upload everything in one video or not. But I don't know. But anyway, there's 2 forms of spreadsheets that we'll look at, and I want to take a look at these sort of with the calculator and then sort of with Excel. So the upcoming videos, the next 2 probably, or maybe even the next 1, depending on how much I get accomplished and how much I don't get sidetracked like I'm doing right now, will depend on how many videos. But anyway, what you'll see is an amortization schedule typically has information provided different ways. I'm going to show you 2 different ways. This is the one I prefer. And then I'm going to show you in an upcoming problem the one that you will see on your My Math Lab assignment. So the one that they prefer. Okay, I don't like the way they do that, but I don't have any way to go in and change it. So I'm going to, instead of kind of throwing you to the wolves and having you just figure it out, I'm going to give you an illustration in this video. But anyway, it's really easy to do. For example, I'll tell you what, let's just keep it like this. So I guess the first thing to realize is that the Smiths purchased a house for $175,000 by making equal monthly payments for 30 years. A copy of a partial amortization schedule, which presents only the first 3 months, is provided. So let's go through and make heads or tails out of what this is actually telling us. So this is the first period. So they start out owing the bank $175,000. Now, again, when you choose on your calculator end, you guys remember that? I made kind of a big deal about that because it is a big deal. When you come down here and do finance and TVM solver, and you come down to the bottom where it says end, if you do begin, you're choosing a different payment schedule. Banks usually use end. It's called ordinary interest calculation method. So it's kind of weird that when you go in and you actually borrow money from a bank, they'll tell you that your first payment isn't due for 30 days. I've even seen your first payment's not due for 6 months. And people are like, oh, wow, that's awesome. Well, really, it's not awesome because that $175,000, which is the biggest balance you will ever have to the bank, would sit there and draw interest against you for 6 months. Well, that's not what happens here. This is only per month. So the $175,000 sits there and draws interest, and the interest for that period is $1,166.67. Well, obviously that money is added to the amount you started out owing. This is interest. That's the way life works, okay? And then we have the balance after the payment. This 174,882.58 becomes the starting balance for the second period. We repeat that, but you can see that the interest is lower because part of your payment up here not only went to interest, it went to reduced principal. So you've reduced your principal down to 174,882.58. So your interest for that period will be less, and more of your payment will go to reduce principal than it will for interest. So again, when you go into a bank and they tell you that, well, you don't have to make your payment for the first 3 months, say no. Say, I want to make a payment today if you can. It's going to blow their mind. They're probably going to tell you they can't do that, but they can. And it will save you a little bit of money in the long term, or just play the game and make your first payment a month later. It's not going to be a substantial difference, but there will be a difference. So anyway, this is just kind of a recursive thing. We just continue doing that. Well, first thing I say is how much was their monthly payment? Well, that's really, really easy because if after the first month of our principal drawing interest, we reduce it down to 174,882.58, then the difference in this amount and this amount has to be the payment. Because this is the balance plus the interest. This is the balance after the payment. So, guys, payment's going to be really easy to find. It's going to be, we don't even need the calculator for this stuff. The payment is the 166,166.67 minus what you've reduced the loan to at the end of the first period of 174,882.58. So your payment for this is $1,284.09. Now, the next thing it says is what was the annual interest rate charged on the loan? Well, what we can do here is we can use some information, and I want to do things this way here, okay? How much interest is earned here? Well, even though we have a compounding situation, this is where things get complicated. I think it's kind of hard to wrap your mind around this at first. When we look at this entire 30 years, we have a compounded situation. But within each period, make sure you negotiate a simple interest calculation plan. So everything, again, for the 30 years is compounded because we have interest that is compounded per period. We make a payment away and we start with the same Our ending balance, our beginning balance is the same as the ending balance the previous period. So that's the compounding situation. But if we come in and just isolate one period, for example, just isolate this, we want a simple interest plan because that's less than a year. And when we have that situation, we can easily use the I equal P times RT. Well, our interest for the period is clear. Our principal for the period is clear. Our rate for the period is clear. We just solved that. No, we didn't either. That's what we wanted to solve for. And the time is clear. 1/12 of a year. Guys, remember, T is always in years, okay? And a month is 1/12 of a year. Now, if I'm going to solve that, first thing I'm going to do, I think I'm just going to multiply both sides by 12. That's going to get rid of all this fraction business over here, right? So let's do that with your calculator. I don't have a calculator. I kind of like to keep some of that. Let me see if this one works. Nope, doesn't work. Let's see. I would say I have 10 to 12 calculators in my house, and none of them work. Yeah, they do. This one works. All right, so first thing I would do is I would take the, we'll start out clean. So I would take 1166.67 times 12. So I've got, it doesn't matter what I've got. So this stuff goes away because I multiply by 12, and 12 times 12 just gives me 1 for obvious reasons. Now the next thing I want to do to isolate that R is I want to divide that by 175,000. All I have to do is just go divide it by 175,000. And I can see that my interest rate multiplied by 100 is 8%. All right. If you're buying a house in these days, this time right now, and you're paying 8%, you must have really, really, really bad credit. That's the way it works. The more risk that the bank feels like it is taking on you, the higher interest rate you're going to pay. Now, what is the balance after 10 years? Now, I tell you what, this can get really wacky because we'd have to go through how many periods? These are months. So we'd have to go through 120 and calculate this by hand. I don't know about you, but I don't want to do that. I don't want to do that at all. So what I'm going to do is I'm going to put this information in my calculator and get the TVM solver set for this problem. Get over here where it makes sense. So guys, we got 30 years times 12. We should be pros at this by now. And again, I don't ever want to see you walking in buying a car without having this goofy calculator strapped to your side. All right, so we've got 8%. We've got a balance of $175,000 starting out. We know that our payment is, remember guys, this has got to be negative because it's a payment. What was our payment? $1284.09. And we got at least something to solve for. So let's just go second function, solve for that. And we can see that we get a future value of 0. So what I'd like to do here is kind of manipulate it a little bit. Let's go in and put 0 there. Let's go back and solve for our payment. And you can see that you get 1284.09 when it's rounded correctly. Okay? So everything's working out perfectly with what we found with the interest rate of 8% and the payment of 1284.08. Well, guys, this makes it really cool because now we can use that key in our calculator, that balance key, to come in and what was it, after 10 years? So our PYCY was in months, so 12. So we'd have 120 periods. So guys, your balance would be 153,518.23. All right, so we're going to learn this stuff, and we're going to, we're going to, bump up the ante just a little bit. Pretty quickly here. Number 2 is kind of a tough problem. Okay, actually, it isn't. If you just, I guess I should read the problem before I start saying whether it's difficult. Yeah, this one's got some multiple steps, and multiple steps. Usually students like to do just one thing and be done. Well, these problems are going to drive you crazy if that's you. But guys, this is all doable, and it's important stuff. It's important stuff for you to understand, not only with your own personal finance, but if you go out and with a business degree and represent a company, these fundamental and very just basic principles in the mathematics of finance are things that I think you should know. So anyway, a couple wishes to borrow money against the equity in their home. A loan company will loan up to 80% of the equity. They don't want to get all the equity in the house, because if you've got $100,000 in your house equity, they don't want to give you $100,000, because if you take that and run, then it's going to be hard for them to recoup all their money by the time they hire a realtor and by the time they go through cleaning up your house and selling it and yada, yada, yada. So they'll give you 80%, leaving them a little bit of room in case you do bail on them. And I just define equity. Equity is the difference in the current value and the amount that you owe on your home. So the simplest case, if your home is worth $200,000 and you owe $100,000, then your equity is the difference of the $100,000. So this couple purchased their home 15 years ago for $163,500. Their home was financed with a 30-year mortgage at 5%. Equal monthly payments were made. The market value of their home is currently $200,000. After making the 180th payment, they apply to the loan for the maximum loan. How much to the nearest dollar will they receive? Sometimes it happens. I know when that you find yourself, for example, 180 payments. That's 15 years? 15 years. So, sometimes you find yourself 15 years later, maybe needing some money. Maybe you want to renovate your home. One of the surprising things I think about our adoption is when we first pursued our adoption, actually both adoptions, the second one not so much because we knew what we were in for, but the first one we didn't have any idea of the financial responsibilities, and in other words, how expensive adoptions are. And I remember Tanya and I felt kind of weird because we felt that that everybody who adopted would just overflowing with massive amounts of money, and it turned out we traveled the first time to China with 18 other families. There were 19 total, and it's surprising how many actually took out home equity loans. They didn't have the $25,000 just laying around in an account. They did exactly what we're doing here. They took out a loan on the equity in their home. So sometimes you need the equity in your loan to make improvements. Sometimes maybe it's your wife's, you and your wife, or you and your husband's 25th year anniversary or your 50th, and you want to do something really cool, and you don't have the cash laying around. Maybe your cash is in your IRA, and you want to borrow against the equity of your home. There's nothing wrong with that. People do it all the time. So let's see in this situation how much money that they could get, okay? So the first thing I would want to do is I would want to set up the situation in my calculator. All right, so let's see what their monthly payments would have been. So initially, even though they purchased their home 15 years ago, that's irrelevant. We've got to go back to the day they signed their mortgage. What was their payment? So they agreed to a 30-year mortgage for monthly payments. Their interest rate was a smooth 5%. They bought their house for $163,500. Come on down, make sure we don't get sloppy. Future value 0, FYCY 12, so cool. So hit second. So their payments were $877.70. All right. Now we really don't care about that. We don't care what their payments are, but to be able to use our balance key, we have to have everything in this calculator set for the existing problem. So now we can use our balance key. So we know that after 15 years, their house is worth $200,000. But we need to see how much they owe the bank. So guys, that's really easy. Hit second function, quit. Go to your apps. Go to your finance. It's on number 9, your balance. And we want to know, after making their 180th payment, how much they owe the bank. Well, they owe the bank $110,990.19. But apparently they've had an appraiser come in and get an appraisal in their house for $200,000. So their house is worth $200,000 minus what they owe, and they can get 80% of that. So the maximum loan that they could apply for would be $71,207.85. That would be the maximum loan that they could get. And again, how do we get that? We used our balance key. This is how much they owe the bank. They had an appraisal done. Their house is worth $200,000. They have to take away how much their house is worth minus what they owe the bank. They get the equity in their home. Their equity in their home is $89,009.81. But banks are typically only willing after we had the whole Fannie Mae Freddie Mac carousel disaster, bankruptcy. All kidding aside, the banks want to protect themselves, so they'll give equity up to 80%. So you see that 80% a lot. A lot of times, if you buy a house, banks will want you to put 20% down. Well, that 20% down keeps them at a safe investment in your home in case you default on the loan. So, and if you want to find something kind of interesting, if you like politics and if you like debate about who's the best party, Democrats, Republicans, whatever, those things just annoy the hell out of me. But maybe you like it. Look up subprime, the subprime market. Well, look it up. Make up your own mind. I'm just paid to teach you stuff. I'm not paid to change your political beliefs or enforce or reinforce or strengthen or challenge or whatever. That's all right, gang. Let's go into other stuff. All right, number 3, another way of presenting an amortization schedule is the following. And guys, this is the way, the only reason I'm doing this, I don't like this way, but this is the way that my math lab presents it. And actually, it's the way most mathematics of finance textbooks present amortization schedules. I know by having a My Math Lab account, I can draw, when I put these questions, when I select these questions for y'all's assignments and y'all's examinations, I can choose from every textbook that they have. And I have tried to find a textbook for mathematics of finance that prefers the way I do it. I haven't found one yet. They all do it this way. So I want to run through how you could actually use this way, and there's going to be a question on here, so you're going to want to well, you have vested interest. So we'd like to amortize a loan of $200,000 by making semi-annual payments for 10 years. Now, what in the world does semi-annual payments mean? Well, guys, it means 2 times per year. Biannual, there's sometimes people call this biannual. Well, there's some confusion with biannual because biannual, and there's a biennial or something like that. I don't know. I get confused by it. Semi-annual's clear, and that's why people use this. But biannual could mean twice a year or every 2 years. So, guys, semi-annual's clear. It's twice a year. So for the payment number 0, what we're going to start out with here is we're going to start out with the unpaid balance of $200,000. And then we're going to come in at the beginning of the first. And we're going to calculate our payment. So I'm going to use my calculator to calculate the payment because that's the way I roll. Hopefully it's the way you roll too, all right? So we're doing 10 years, twice a year, so 10 times 2 gets you out of your comfort zone of 12. Interest rate is 4.5. Now this is something that would be very reasonable to calculate for a business. Businesses do annual payments, semi-annual payments, quarterly payments based on cash flow. And I think I've told you this before. When I had the golf course, I was a part owner. I actually had a very small interest. I owned a small percentage. I wasn't a majority owner, but we bought some carts, and our cash flow was best in July and August, and even September. So we had our payment on our carts due once a year in August when we had the most money. We certainly didn't want to have our cart payment due in is that 20,000 or in February when in Kentucky golf business isn't really good in February. All right, guys, we got semi-annual going on here, so don't forget to change that to a 2. And we can see that our payment here is $12,528.41. So $12,528.41. Now that's not going to change. So I'm going to make that payment every single period. So I can just go ahead in my partial amortization schedule, I can go ahead and write the payment there. Now the interest. Now how are we going to calculate this interest part? Well, the interest here is going to be the principal times the rate times the time. If you get sloppy here and put 1/12, then we're not doing monthly payments here. We're doing semi-annual payments. So the time, again, in this I equal PRT, and I'm going to repeat that because this is a source of confusion, source of getting sloppy and students missing questions. They'd want to put a 2 there, or do something goofy, and always put 10 or something like that because it's 10 years. You're calculating the interest based on, you got tunnel vision. The only thing you care about is that first semi-annual, that first 6 months. Okay? So you've got to let your formula know that it's over 6 months, which is half a year. So guys, we put that in our calculator, and I'm going to. So I'm not going to show you that because I think we can all handle this. So I've got the 200,000 times the 0.045 times, I am going to show you this too because I want you to make sure that, so when I put the month, make sure always you put fractions in parentheses. That's a Darbroism, and the reason I tell you that is because you need that. It works. So your interest for is $750. Now, the next thing it asks for is the unpaid balance reduction. Well, if you make a payment of $12,528.41 and $750 of that goes to interest, that doesn't seem right, guys. It doesn't seem right. It doesn't seem like enough interest. Well, uh, huh. Well, let's see. Let's just go ahead and play it out. I may be doing this over, but my quantitative literacy is kicking in here and saying that 12528.41 minus 750 interest, that that has 11,778.41 that is reducing the principal. Okay. Did I do anything goofy here? We have a loan of $200,000. We have an interest rate of 0.045. Nothing goofy there. We're doing this for a half of a year. Nothing goofy there. All right, let's make it happen then. So the unpaid balance reduction. Unpaid balance reduction. So I'm going to take that away from the 200,000. $78.41, and I have reduced the balance to 188,221.59. Interesting. All right, let's just go ahead and see what happens here. For the next payment number 2, my interest is going to be on 188,221.59. It's going to be multiplied by 0.045. Semi-annual is 1/2 of a year. So what I'm going to do is I'm just going to use the answer key, and I'm going to multiply that by 0.045 times 1 divided by 12. 1 divided by 2. Half a year. So the guess what did I do wrong? That makes much more sense. Well, I have just thoroughly screwed up this problem. Huh. Guys, I'm just not buying this interest part of 750. You guys probably know what I'm doing wrong. You're probably sitting there screaming at me. Let me do that again. So I've got the 200,000 times 0.045 times 1 divided by 2, which is $4,500. That makes much more sense. My quantitative literacy was kicking in. It's like, this just didn't work. I'm just curious. I got to go back and see, what did I do? I did something wrong. That's the one I just did. And you guys probably know exactly what I did. I did months. I sure did. You guys are probably screaming at me, why are you doing monthly when you just said up here that we're making semi-annual payments? Well, anyway, I'm really glad. I could edit this out, and you guys would never know that I made a mistake. But I'm not going to do that. I want to keep it honest here. We all make mistakes, and I just made one. All right. But it does make more sense. And again, my quantitative literacy was kicking in and saying, this is not possible. So, guys, of the 1258, 12,528, I should say, 0.41, $4,500 of that goes to interest. So the amount that goes to reduce the principal is $8,028.41. Now, guys, that goes there, and that goes in that box right there. So don't, I'm off one. So now this makes much more sense that the 12,000, the 20,000 or the 200,000 is going to be reduced by the 8,028.41, which gives you, yeah, this makes much more sense. So 191,971.59. Let me get that over there where you can see it. Okay. Now, much better. So now the second, we're going to take 191,971.59 times the interest rate times 1/2. So I can just use the answer. Again, your answer key is right here. And I can multiply that by 0.045 times 1 divided by 2. So the interest on that period is going to be 4319.36. So partitioning out this payment of 12,528.41, $4,319.36 of that is going to go to the bank. How much of it, the rest of it, I don't know about you, but I like my way of doing the spreadsheet better. So more of your so 8209.05. Again, these two numbers, this tells you how much goes to the bank. This tells you how much goes in your favor to reduce your principal. So we're going to take 191,000, and this is going to be so much easier when I put up your spreadsheet. And then we're going to subtract 8209.05. This is going to be so much easier when I show you how to do this on spreadsheet. So 183,762.54. Now, that's going to become my new unpaid balance for this payment. So we're going to do the same thing. We're going to take that amount times 0.045 times 1 divided by 2. So 4134 $1,233.66 is the interest for that particular period. So of the 12,528.41, subtract out the 4134.66 that goes to the bank, 8393.75 goes to reduce our principal. So I think this is good for learning because it shows you that over your increasing payment, well, not increasing payments, but your first month, not first month, first 6 months, second 6 months, third 6 months in this problem, that your interest is decreasing and your amount going toward principal is increasing. So it's an interesting dynamic and an important dynamic in calculating payments and looking at amortization. So I see the learning value here. So 183,762 is what we owed in the previous, and we get to reduce that 8393.75. So we've reduced our loan to 175,368.79. Now you may be wondering, does your calculator do this? Does it have a way to do an amortization schedule? It doesn't. But guys, there is a way that we can create all the unpaid balances for this particular loan. Let me show you how to do that. This is actually kind of cool. It's not as cool as a spreadsheet, but if you've got your calculator, it's something that you can do very easily. The first thing you got to do is you've got to go into TVM Solver and set up the problem. Okay, that information has to be stored, and you can see that I've already got that. I've got my payment of $12,528 per 6 months. PYCYs are 2 for obvious reasons, twice a year, and I've got 20 periods because I have 2 per year for 10 years. Once I get that, here's something I can do. It's kind of cool. Get out of that and go into Y equal. So right up here, Y equal. And then let's go get your balance key. So remember, we do that finance. It's number 9. So it'll put your balance key as a function in your Y editor. Well, guys, right here, we want our function, we want our balance to be a function of something. And in here, we let it be a function of X because we're going to let X run from 0 to 20. X is going to be what payment we're actually doing, okay? Now, if you hit enter, nothing's going to happen. But you have something called a table on your calculator. And right up here, you can do what's called a table set. Hopefully you guys can see that. Let me try to get it a little bit. Okay, maybe a little clearer. But right there, you got table set. So if I hit my my blue key and go to table set, it can tell me where I want to set my table, and then this triangle, TBL, this is just delta, change in. So we want our change in table. So I want my table to start at 0, okay, because that's what I've got over here. And I want to change by 1 unit. So I put change in table equal to 1. Now I can come over here and hit this table, so second function, and I can see my values. And you can see that each of these corresponds. Now it doesn't give you the dollars, and it just gives you the dollars. It doesn't give you the cents. But you can see that each of these corresponds to the 200,000. Next we had 191,972. Next we had 183,763, which you see right there. And then you get down to 175,369, which is right here. So we can get these numbers over here on our calculator, but that's all we can get. Now, it's probably a pretty fancy smancy way to come up here and insert maybe a heading and actually get this, but when I say this, get this amortization schedule just as we see it. But I wouldn't spend too much time doing that because I can show you in Excel how to create one of these really kind of slick, and it does the job. So, guys, you're going to have one of those on your homework assignment. In fact, as soon as I end this video, I am going to go to my math lab and post your assignment immediately. So, guys, have a good one.